Start video. Greetings. Let's see, let's open up MATLAB, I suppose. All right. Welcome back. We are, let's see here. So chapter 8, I've, at the request of somebody, I don't remember who, I've pushed off chapter 8 assignment until this Saturday. I'd imagine probably not just one person wants a little more time on that, and that's fine. And we also have now we have 2 full weeks before chapter 9 will be due after we cover today's work. So no school next week, of course, for spring break. And so that gives you extra time to get things turned in, which is good because chapter 9 is a big one. We might actually use 2 weeks to do chapter 9 in the end. It has so many different big deals in it. We'll see. Make sure that if you have questions on chapter 8 that you send me a message or something, come get some help. I have had several people ask questions about loading data files. Remember the file that I gave you, the files that I give you in the assignments are .mat files. And I don't think that MATLAB will read a .mat file, but it's a little bit convoluted the way you do it. So you need to go in there and change it to a .dat file. And the way that you do that is you go ahead and open up the file. Let's show you how to do that. So you go in here and that is not it. That's the video participation. I want the homework. Homework. Here we go. So you go ahead and you go in here and you click on it. If it takes you to Google Docs or something like that, you want to go up here and press the download button to download it into your computer. And then it's probably save it in your downloads file. You can open it with Microsoft Word or you can save the file either way. That's not the one I'm looking for anyway. This is the one I'm looking for. So the hottub.mat file. For me, it just downloaded directly to my downloads, I think, when I clicked on it. Maybe not, but I think it did. So anyway, I'm going to go over here and check in my downloads. And it doesn't look like it's there. 2 more. Let me take this. Take a look at it here. Looks like it didn't download it, so let's try to download it. Question 2, 3. Why is it not letting me click on it? Save link as. Not letting me do it. I don't know why I can't click on it. Anybody else have this problem? Because I don't think I've tried to click on it on this computer before. I'm going to try a different web browser so that I'm not using I don't know what's going on now. What is it doing to me? Open math. Open link in new tab, maybe. Maybe that will help me. Maybe not. I'm going to try the student preview instead of the teacher preview. So it opens that one and it does it in Google Docs. So if you do open it though, some people were able to open it and it opened a little box in Google Docs And I think the reason it's trying to open it in Google Docs is because I'm logged into my Google account and Mozilla is connected to Google somehow. But if you do that, it should give you a download option up here, and you should click on that instead of anything that it shows you in the window down here, because that seems to work better. And then if you're clicking on this one, so here, this is what it does. If you click on the hottub.mat, it'll give you this option to download here, or you can download it up above. I would recommend using the up above because sometimes this one gives you an error. Let me try and see if it does. In my case, it doesn't, but in some cases it did. In my case, it actually recognizes that it's a MATLAB file, so they tell you they give you the option to open it with MATLAB, or you give the option to save it. I would go ahead and save the file, and it's going to save it to my downloads, and then I'm going to carry it from my downloads to MATLAB, and then I'm going to rename it. And the way you rename it is when you get into MATLAB and you bring that file over here. I'm going to do that just by dragging it over. It's a simple way to do that. Goodness, I have too many things open. It's crazy. I need to clean up my computer. So I've got this hotdub.mat file. I'm just going to drag it over into here and drop it in here somehow. Maybe not. It should allow me to drop it there, but it doesn't want to. Let's see if it's there. So I dropped it into this folder here at hotdub.mat. And if you double click on it, in some cases it will open up the, there we go. In some cases it'll open up a separate window. In this case, it's just giving me this error. And so it looks like it knows how to load it. It's just we're not loading it the right way. So what I'm going to do instead is I'm going to just click on it and change this to a hotdub.dat file, which happens to be a file that MATLAB will import using its import wizard. And so you get to here, and I'm going to go ahead and import the selection. The selected data is just these two. You can actually just click this first line if you want to, and then import the selection. And let's see what it does. Did it do it? Yes, it did it. So it's right here. So it imported into my workspace. Now I can double click on it and see that data is in there. These are the different temperatures on the day, on the different times. So the thing that it doesn't import, one of the errors that it gives is it's not importing the time. These are the times up here that it's not importing because it's not recognizing them as numbers. And mostly because they've been entered in a weird way. But you can just use this data and know that this is the first hour of the day, this is the second hour of the day, the third hour of the day, and so on. So you can use the index in the table to do that. Or you could change these things up here in the hottub.dat file. You could change these things to equal numbers. And I can't remember exactly how to do that, but there's a way to do that. It's some kind of command you do with unimportable cells or something like this. Yeah, I don't remember how to do it. I don't think I've ever used the import wizard to do that actually. But it's not absolutely necessary by any means. So anyway, that's how you're going to bring in MAT files, is you're going to change them to DAT files. And eventually I probably have to go in and just change all those files the way they're saved so that they come in properly. But this is actually just this is another part of programming that you'll get a lot of experience with if you do programming at all, is importing data. There are literally millions of ways that data is stored. Sometimes it's just in a file that's kind of like a garbage bin where they just throw the numbers in. And sometimes it's got some kind of delimiter in it, so you know the difference between. Sometimes you actually have to go in and extract. Sometimes they just put them in as a string of numbers, and you have to say, I want these in groups of 5. So you have to make your own delimiter. You have to make your own organization for it. It can get really crazy the way data is saved by in different situations. And so each situation requires that you kind of figure out how to bring in the data in the best way for what you want to do. And it's usually not ideal in any situation, unfortunately. So anyway, that's something that I've had questions about. I've also had a couple people come and ask me questions about the flow charting document. Just as a reminder and a clarifier, I do want you to complete that document, which means the two or three examples in there of flow charting, and then all of the questions. And some of the questions at the end include creating flow charts, right? So you're doing more than just the flow charts that you fill in. You're also going to create your own flow charts, making all the shapes. And you can do those by hand and just, scan them and send them to me, or you can do them in Word using the flow charting tools in Word and type them out and then send them to me, however you want to do it. I prefer to do them by hand. Something that I mentioned, but I didn't really talk about a great deal, is that when I'm doing flow charting, I have a tendency to write out an outline without using any flow chart symbols to begin with. So I write an outline of what my program is supposed to do, and maybe kind of the general flow of it and everything, the general idea of the program, just written out with maybe words and arrows or something. And then I go back and I say, okay, for this one, this is an input. For this one, this is a calculation. For this one, this is a decision. And then I put the shapes in and then rebuild. Then on another sheet of paper, I actually build the flow chart from my kind of notes that I've taken previously. So just some things that have been asked of me this week, since I've had quite a few people asking questions of me this week. Before we get started, are there any other questions or concerns about Chapter 8 or anything else in general before we move on? All right. Well, then let's move on. Let's move on to repetition structures. With Chapter 9, when we get through Chapter 9, we will essentially be done with the major programming or the fundamental programming skills that every programmer learns when they begin programming classes or they learn programming on their own or whatever. We'll have learned everything that is fundamental to programming. After this, we'll be doing some certain things to apply what we know to different situations. We'll be skipping Chapter 10, like I mentioned. And we'll move on to Chapter 11. In Chapter 11, we're just going to learn how to apply arrays and matrices to different things other than just numbers, because computers can make a matrix of just about anything. And then in Chapter 12, we're going to skip. And then Chapter 13, we're going to skip. And then we'll move on to Chapter 14, where we'll talk about graphics, images. Because images are just arrays again. So it's just another application of stuff we already know. And then in Chapter 15, we'll go on to GUIs. So we only have 3 sections after spring break to cover. And they're all just applications of the stuff we've learned from Chapters 1 through 9. Chapters 1 through 9 are the basic fundamental skills of programming. So after this chapter, you've arrived. You're programmers. Congratulations. Well done. But let's go ahead and cover this stuff. All right. So we actually had a little bit of an introduction to loops when we looked at the flow charting example. Let's see if I can. Can't bring that up apparently. But in the flow charting example, we had that very first flow chart that they showed us of adding the first 50 numbers together, and we had this loop in the flow chart that went through some calculations, and then it went back and went through those calculations again, and went back and went through those calculations again. And this is what we call a repetition structure. There are different types of repetition structures in programming, and we pretty much call them all loops, even though that doesn't fit all of them necessarily. But the first one we're going to learn about is what we call the for loop, F-O-R, for loop, starting on page 319. What a for loop does is it goes through a set of commands in the program a certain number of times that you tell it to go through it. So you might tell it to go through 10 times, or you might tell it to go through this for loop one time for every row that there is in a matrix. You can actually do that. You can actually do. You can actually be very, very creative with this, actually, especially with MATLAB and other programs that are designed to work with matrices. You can also, for the number of times that you go through, each time you go through the loop, you can actually have a thing called an index. The index is a number that is assigned to that run through the loop. Now, in many programs, that run through the loop has to be sequential indices. So if you want to go through the loop 5 times, then it has to be 0, 1, 2, 3, 4. That has to be your index. Those have to be your indices, your indexes, which is actually indices. But in MATLAB, you can choose the numbers. You can choose it to be 1, 3, 5, 7, or you can choose it to be, you can choose the index to be whatever you want. And every time it goes through the loop, it'll have this number that's in the loop that's equal to that index number. And you can use that index number to do things with, to do calculations with, or other things with, whatever. So this is the basic idea. And let's do something very simple. We're going to do this loop that's here on page 319. And to start a for loop, you start with 4. And it highlights it blue so that you know that MATLAB recognizes that command. And then you're going to define your index. Now the index, you can call it index if you want, but most people give it a letter name. Very common names are I for index. Another one that's very commonly used is N or M for some reason. N for number, I guess. M because it comes after N, I don't know. But there are many different kinds, and it doesn't really matter what you call it, just so that you know what you called it and you call it something. So in this case, they call the index K, and that's perfectly fine. And we're going to set K equal to a matrix. It needs to be set equal to the numbers that you want to be your indices for the duration of this loop. So we create a matrix, and in this case, we're going to do 1, 3, and 7. Perfectly fine. You don't put anything after that line, and you go to the next line. So on the next line, they're just going to say K, which is going to print this number to the screen. And then at the end of the loop, you hit end, and then you go ahead and you hit return. And what it does is it goes through the loop and it prints off K the first time through the loop. The first time it goes through the loop, K is equal to 1 because that's the first index you chose. The second time it goes through the loop, it does it again, but the index is now 3 because that's the second index and it's the second time through the loop. The third time it goes through the loop, it prints the index K equals 7 because that was the third index we chose, and K equals 1, 3, 7. We're good to go. Now, what if we want to do something with that index? We can essentially write the same piece of code for K equals 1, 3, 7. Actually, they're not doing that. We could do it. Let's do it anyway. If we do for K equals 1, 3, 7, we can say K equals K plus 2. And let that print off. Okay. So, actually, that'll be confusing. Let's not do that because we can do that. We can reassign K, but we don't want to. We generally don't want to reassign an index variable of a for loop. So we won't. Let's go ahead and do, let's call it A equals K plus 2. And then let's end that. So then it's going to print off A equals 3, A equals 5, A equals 9. We've added 1 to every time we go through to K. What happens if we do this and then we do reassign k. Let's see if anything weird happens. I'm suspecting that something weird might happen, but I'm not sure. Turns out it doesn't change it any. It's just 359. So what's happening in this case is that as we go through the first time, k equals k plus 2, we get k equals 3. So it puts it down to k equals 3. And then it comes back here. And the second time through the loop, it actually reassigns k to equal 3 again, which it did anyway. And then it goes through again and adds to it. And now k is equal to 5. And then the last time it goes through, it reassigns k. Because every time it goes through the for loop, it reassigns k. And that can be a little bit confusing, even though it's not damaging to the loop at all. We don't usually reassign k in a for loop. We often reassign k in a while loop, which is a different kind of loop. But we don't often do it in a for loop, mostly because there's not any reason to. So anyway, in this, they do another one here. They do this one where they instead of saying k is equal to a matrix that's defined using square brackets, they use the colon operator for k1 to 3, right? So for k1 to 3, a is going to equal, they're going to do a equals 5 to the k power, right? Then they end it, and that's great. Now let's see if we can do this. Here's something interesting. Let's go for k -1 to 3. Can we do that? We can. If we go from k from -1 to 3, then it starts at -1. K is equal to -1, and we get 5 to the -1, which is 1 over 5, which is 0.2. And then it goes to 0, which is 5 to the 0, which is 1. Then it goes to 1, which is 5, and then 2, which is 25, and 3, which is 125. So your index can be negative numbers as well, and it can also be 0. You can even do, let's see what we can do here. Let's do this colon operator, and let's go from -1 to 3, but let's do it in steps of 0.5. So now 5 to the -1 is 0.2 like it was, but we're going to take a step by 0.5. So instead of going from -1 to 0, we're going to go to -1 to -0.5. So 5 to the -0.5 is actually 1 over square root 5, which is actually this number. And then 5 to the 0, of course, is 1. And then 5 to the 0.5 is the square root of 5, which is this number. And then 5 to the 1 is 5. And then 5 to the 1.5 is 11.1, and so on and so forth, right? So you can actually have fractional or decimal numbers as your index, which is, again, very useful. This is not always possible with other programs, or it's, I guess possible is a bad word. It's not always easy to do this with other programs. Some programs can do this easily, some cannot, but MATLAB does this extremely well. It allows you an extremely easy way to create many different ways to index numbers through a loop. Here's a great one, actually. This one's nice. This is at the bottom of page 320. We're going to go from k equals 1 to 5, it looks like. For k equals 1 to 5, and then we're going to say a of k is now equal to, so what am I doing there? Is equal to k squared, or k squared, turns out. Not capital K, lowercase k. What am I doing when I say a of k or a parentheses k? What does that mean in MATLAB speak? When you have a variable with parentheses after it and a number in there, and k is a number, that means that you're selecting an element of an array. So the first time we go through this, it says a of 1 is 1 squared, which is just 1. But what it's telling us is it's telling us the first element of a is going to be equal to 1 squared. And so it puts 1 into the first element of this array A. It makes an array and puts it in the first element. It turns out that the first time through this loop, that array only has 1 element. But the second time it goes through the loop, it says A2 is going to equal 2 squared, which is 4. And A doesn't have a second element. But MATLAB knows that if you call an array and tell it to put a number in somewhere in that array, that it creates that element, and anything between that element and the last previous element will be set as 0. So let's see what happens. I'm going to go ahead and end this. And A, the first time through, A is equal to 1. The second time through, it adds another element on and makes it equal to 4. The third time through, it adds another element on, makes it equal to 9. The fourth time through, it adds another element and makes it 16. So what it does is every time it goes through the loop, we tell it to put a new element in with this number in it, and it adds that element onto the array. What if we skipped one of these? What if instead of going from 1 to 2 to 3 to 4, we went from element 1 to element 4? Well, we can do that. We can write that code. We're going to go, instead of for k equals 1 to 5, we're going to go k equals 1, 4, 5 as an array, as a matrix. And then we do the same code that we just did before. And when we do this, what just happened to it? Oops, I forgot to do something. I have to clear out A. Clear. So now A is not there anymore. But I have to clear A out and then to do this again. So for k equals 1, 4, 5, and then I do the same code here, and then I end it. Now, the first time it goes through the loop, it puts 1 in the first element. And the second time through the loop, k is equal to 4. So it puts 16 in the fourth element, and that means it had to create the second and the third element. And since I didn't tell it what to put in there, it just puts in 0 automatically. And then the last one, it puts in 5 squared in the fifth element. But it has zeros here now because I never told it what to put in there, because it didn't go through the loop when k was equal to 2. It didn't go through the loop when k was equal to 3. It went through when it was equal to 1, when it was equal to 4, when it was equal to 5. The loop only executed 3 times because there's only 3 indices. Now, of course, these are just demonstrations because we can actually make these arrays much faster than making them using loops, right? Making an array in MATLAB is much easier than making a loop to make them. Sometimes it's useful to make arrays that way, but it's not usually the best way in MATLAB. Let's go ahead and look at a way that we can use these with a little bit more code to do something a little more interesting. Page 321. Always a good idea to clear things out. And let's go ahead and do this one. So we're gonna have this array of scores. They have a typo there. It should be scores equals this array 76, 45, and they're 98, 97. So we have 4 scores. And then we're going to create a variable called count. We're going to start off with count equals 0. And then we're going to go ahead and create our for loop. For k equals, we're going to go from 1 to the length of scores. Now, why would we write our code like this? What's the purpose of using code that includes a MATLAB function, which is the length function? Well, this code could then be used for any array of scores, not just the one we've entered in just now. I could write this code and I could use it for this class that has 1, 2, 3, 4, 5 students in it, or I could use it for another class that has 15 students or another class that has 582 students, because it's just going to keep running this loop until it gets to the end of the array of scores, or it's going to run it however many times it needs to get through the scores. And then inside this loop, I'm going to go ahead and put in an if statement. Now I'm going to indent a little bit here to make a little more sense, I guess. And we're going to go if scores, and I want to pick the kth score. So if scores k, when I go through the first time, it'll look at the first score. When I go through the second time, it'll look at the second score. And it will say if it's greater than 90. If scores k greater than 90, then I'm going to say count equals count plus 1. Can anybody guess what this program is going to do now? What is this program doing?
It records how many times the for loop, how many times we have the loop.
Well, it definitely will do that, but
We're putting the count plus 1.
yeah, so it's the count plus 1, but it's only doing that if scores at k is greater than 90. So it's counting.
Counts, scores greater than 1.
That's right. So this is counting how many scores are greater than 90. If it goes through here and the score is not greater than 90, then it's not going to count anything, right? We could actually change this a little bit. What if we wanted to count how many scores were greater than 90 and how many scores are less than 50? Could we do that? Could we add in another thing here? Sure, we could. We could do an else if, right? But we didn't. We just put in this. So we get to the end here. We're going to end we have to end the if statement. We also have to end the for loop. And then we go ahead and run it. And we're going to go ahead and display now count. Turns out there are 2 scores greater than 90, right? So you could expand that code. You could expand that code for everything greater than 90, everything between 80 and 90, everything between 70 and 80, and so on and so forth. You could count up different grades that you have, which of course we also have a function for. The histogram function does that, right? The hist function. We can do that a different way. But this is essentially how you do this using a for loop, how you do this in most programs, is you create this this for loop that counts, goes through and through, and this will go through it however many times you've got scores. If you've got 100 scores in there, it'll look at it 100 times, right? Now you can start to see, hopefully, the advantage that MATLAB has over most programs. MATLAB can look at the entire array at one time and tell you how many scores in there are greater than 90. It can do it all at once. It doesn't do it with using loops. We can make MATLAB do it using loops, but this takes much longer and much more computing power than using MATLAB's internal commands, because MATLAB is designed to look at the array. It's designed that way in its software, instead of looking at individual elements of the array. We could actually time them. This is something that we used to do, is we'd create 2 functions, one that used the for loop to look through an array for something, and one that used MATLAB's internal array functions, matrix functions, to look for something. And then we would time them side by side on 2 different computers. And you could see that it was like 10 times faster using MATLAB's functions. And most people just assume that MATLAB's functions, if you looked at the code inside of MATLAB's functions, you would just find a for loop that would be looking through the array, but it's not true. That's not how it does it. It does it very differently, because it can see it essentially, it can essentially evaluate the entire array at once, which is beautiful. It's a beautiful thing. And other programs can do that. Most of them are not as user-friendly as MATLAB, but MATLAB was designed specifically to be user-friendly and to be able to look at these arrays as a complete thing, as a matrix. All right, so let's see, where else? What else here? So here we do this. Now we're going to do a one where the array is now a matrix. It's actually a two-dimensional array, or a two-dimensional, or a matrix. This is at the bottom of page 321. Let me go ahead and clear things out again. Always a good idea when you're messing with these things, especially since we keep using the same index variable. I have a tendency to not use single letters as my index variable because I prefer to have my index variables to be more descriptive of what they're doing. But that means that you have to use that as in different, it's just a little bit less elegant as far as the actual code, I guess, but I prefer it. You can do it any way you want. I also prefer not to use the same index for everyone because it starts to get confusing to me, but they do this. So we're making this array. Let's go ahead and make this array. It's going to be 1, 2, 3. Oops. 1, 2, 3. And then 1, 4, 9. And then 1, 8, 27. So we have 3 numbers, and then they're squares, and then they're cubes, right? So that's our K array. And we're going to say for K, and in fact, I think we can do it just like this. For K, I don't think we have to say what it's equal to because we already did. Let's see if this is true. Oops, apparently we can't. So it's expecting it to be equal to something, and that's fine. For K, you can't define it first and then just say for that thing. I thought I could. And you don't want to suppress that. You don't want to put anything after that. So for K equals this thing, we're going to say that A equals K, and then we're going to go ahead and take its, turn it into a column. But I always forget what they call that. But anyway, we're gonna change that into a column. Call it A, and then we're going to end it. And what that does is it takes now A goes through the first, goes through the first time, and it takes the first thing in each row. Well, it takes the first column, sorry, and turns it into a row. So the first, these are the first numbers in each row, and now they're a row. These are the second numbers. So this is the first column, essentially. Now it's a row. This is the second column in this one, and now it's a row. This is the third column, and now it's a row. But it did it one at a time. It did it one at a time. So this is what, let's actually open up A and K really in the variable explorer and show you what it looks like here. The variable editor. So K, where did K go? What happened to K? K did something funny. 7. That is what it was supposed to do, but I don't think it was supposed to rewrite K. But I did it correctly. So apparently it was supposed to rewrite K. Transpose is what it's called, by the way. This when they put the little parenthesis after here, the single quote, that's called the transpose of K. So apparently this did two things. One thing that I expected it to do, the other thing I didn't expect it to do. And I'm not sure if that's a change from MATLAB because I can't remember if it used to do it this way. But what it's done is it's looked at K. Now K used to be this array that was 1, 2, 3 across here, then 1, 4, 9 across here, and 1, 8, 27 across here. So it took that thing and it looked at each column and it made them into rows. So the first column was 1, 1, 1 of K originally. And so it made a row out of it and called it A. That was the first time through. The second time through, it looked at K and looked at the second column of K, which was 2, 4, 8, and it made A into that 2, 4, 8. And then the third time it went through, it looked at the third column, which was 3, 9, 27 of K, and turned A into that as a row, 3, 9, 27 as a row. Now the reason that I kind of balked at that a little bit is because I don't think that's very illustrative. I think that's a little confusing as to what it's doing or what it's supposed to be doing in my view. And I think it comes down to the way they entered this in, because when you enter this in as this matrix, it's not going to go through the matrix it's not going to go through the matrix element by element. It's going to go through it row by row. So the first time it went through it, K was equal to these three numbers as an array, right? And so on and so forth. So it, no, actually did no, it's not these three numbers, the first column. So it goes through it column by column. So the K is equal to the first column. And that's why the first column, when it's transposed, becomes the A as a row, right? Now, if I was going to do this differently to illustrate what I would like to illustrate is I might do this. Let's do the same code. And then for the second part, let's do A of N maybe, where, let's see, we need to define N first. Let's end this. So I'm going to define N equals N plus 1, or sorry, N equals 0 rather. So I'm defining another index number, and this one's going to be an increasing index that changes every time we go through. So N is going to equal 0, and then I'm going to say for K equals this thing, and then the first thing I'm going to do is say that N equals N plus 1. And then I'm going to come down here and I'm going to use my N index to redefine K, or A rather, A of N now is going to equal K transpose, like that. And then I'm going to end it. And let's see if that does what I want it to do. Left and right sides have a different number of elements. Yeah, so that actually is not going to do what I want it to do because why? Because why? Oh, because of this. This actually has to include colon. So let's do one more thing. Sorry. So N equals 0 still. No, N equals 1 now. So we have to reassign N equals 0. And then I have to do my 4K thing. And then I have to do my index change, which is that. Then I have to do this thing, but I have to say N equals everything in, let's see, row 1, all the columns. I think it has to be this, N column that, I think. I'm trying to think if that's correct. And then I do an and. Yep. So now what it's done is it's turned, so the K vector, remember, was 1, 2, 3, 1, 4, 9, and then 1, 8, 27. Now it's 1, 2, 3 down, 1, 4, 9, 1, 8, 27. So it's essentially transposed the entire matrix, right? It's turned all the rows into columns and all the columns into rows. So that's the thing that I would prefer to show somebody, because I'm not sure that it makes sense what this, I mean, you really have to explain what this has done. I guess the code is simpler for this one, but this one is more illustrative of what MATLAB can do. Because this is another thing that MATLAB does automatically. If we want to do this automatically, we can just define K to equal this thing. Say K equals that, and then we just take K transpose, and it just does it. And it does it much faster and much more efficiently. But the little bit of code that I wrote uses a for loop to do that, uses the actual numbers in the array as indices, and it also uses an increasing index each time. So, and these kinds of things can get hopelessly complicated. You can have all kinds of different ways of doing loops and doing things, different tasks. The key to doing these things is to try things out, to look online and see what other people have done, because a lot of people are very creative with this and really have a great mind for it. I'm not one of them. So I look and see what other people are doing. But beyond all of that is to try to make it as simple as possible. And that's where the flowcharting can come in. The flowcharting can help you to kind of water it down to what actually needs to be done, so that you don't get hung up on some other weird thing, and try to keep it simple, right? All right, so that is the for loop. So they're going to use this for loop in a couple of examples here, starting page 323. They're going to do an example that you did before, creating a table of degrees to radians for a group of numbers, but instead of doing it all at once, using the commands of MATLAB, you're going to do it one at a time, one element at a time, calculating the degrees from the radians, or the radians from the degrees, or whatever. And they show you the flow chart, and then they show you the code. And this is very useful when you're trying to do that flow charting assignment. You get a lot of examples on how this is done. In this one, they actually write some of the code in one of the boxes, which is totally fine. You don't have to, but it's actually pretty easy to do with MATLAB, because the code looks very much like normal math. They do another example, calculating factorials. So that's, like one of the ones that we do in the homework assignment. And then the last one that they do is actually also factorials. It's a different version with error checking as well. So that's for loops for you. What time is it? 2 o'clock. Okay. Let's take a little bit of a break before we go on to while loops. Take 5 minutes or so till about 2 o'clock, a couple minutes after 2 o'clock. Go ahead and get up and walk around, get a drink, whatever you need to do. I'm going to take a break and stretch my legs, and we'll come back in a few minutes. Okay. I see you're uninjured now.
Yeah.
That's good. Did you get to play much?
Well, yeah.
Good. We were there for when you guys were warming up, but then we are a host family for Jordan Moon, so took her out to ice cream after she won the game. All right, so let's do while loops now. So while loops are another type of repetition thing in programming. For loops and while loops are pretty common across pretty much all programming platforms. It's just something that everybody learns how to use, everybody uses. Logan, I forgot to ask if you can hear me today. Can you hear me today?
Yeah, I can hear you.
Oh, good. Okay. So anyway, a while loop, they use the word while for the same reason a for loop uses for. A for loop executes for a certain number of times, and a while loop executes while a certain condition is being met or not met or whatever. And so, so for a while loop, you have to set a condition that keeps the loop running. And really, the only way to illustrate that is to do it. So let's do it. So we're going to go ahead and say k equals 0. We're going to start off with this thing, this variable, and this is no longer an index. This is a condition variable now. So k equals 0 is our condition variable, and we're going to say while k. Oops, I just put that in my thing here. Don't know why I did that. Let's close that. Close that. Close that. Close that. Close that. Okay. So we're going to say while now k is less than 3. And then we're going to have our computation or whatever we're going to make this thing do, make this loop do every time it goes around. We're going to say k equals k plus 1. Then we're going to end this thing and run it. So the first time it goes through, it says while k is less than 3. Right then, it asks the question, is k less than 3? Since we defined k to be equal to 0, the answer is yes. When the answer is yes, it goes through and executes the loop. K equals k plus 1, or 0. So k was 0 before, now 0 plus 1 is now k, so that's 1. K equals 1, it prints it off because I didn't suppress it. And then it goes back to the loop again. Is k less than 3? Well, k is equal to 1 now, so it's still less than 3. So now you say k is equal to k plus 1, that's 1 plus 1, now k is equal to 2. Prints that off, it goes through the loop again. While 2 is less than 3, because k is now equal to 2. Then you say 2 plus 1, k is now equal to 3, ends the loop, and it prints that off and ends the loop. Then it goes back to the loop one more time and says, is k less than 3? Well, now k is equal to 3, and k is no longer less than 3. So that's no, and it ends the loop right there. Right? So the way that they've used this looks an awful lot like a for loop, where you would say for 1 to 3, for k equals 1 to 3, print k, right? And so it's a very, it does the same thing that loop does, but it does it using a different functionality, a different set of commands and ideas. So while loops, you can almost always create a while loop that does the same thing as a for loop. It's not always convenient. It's not always, doesn't always make sense. And it also takes more computing power, because when the computer has to ask the question, is k less than 3, that takes a little bit of computing power to do that. Not a lot, but a little bit. Whereas the for loop just sets a value for something every time it goes through, much simpler. But a while loop does have its advantages, because a while loop does not necessarily have to go through in succession. Here it went through in succession because we said k equals k plus 1. So each loop had a successive value for k that increased every time. But it doesn't have to be that way. You could set a loop you can make a while loop that says, while Jared is awake, we're going to feed him Doritos, right? And as long as I stay awake, I'm going to be fed Doritos. And as long as I'm awake, every time that loop repeats itself, I'm going to get some Doritos. I could get really fat, right? But I could also go to sleep at some random time. So the next time I go to the loop, I'm asleep all of a sudden, and the loop breaks, right? So while loops, because they are conditional, do not have to follow any kind of succession, do not have to follow any kind of time. They just follow whatever condition you set them equal to. So it can be very useful in that way. Let's do one that's a little more conditional. Well, they don't really have any. They do another one where they increase the index. They set k equal to 0, and while k is less than 3, and then they add 1 to it every time, and then they do some multiplication with, they raise 5 to the kth power or something like that. So you can do math within while loops just like for loops. That's not all that interesting. And then they do another thing that's kind of similar to that, but this one actually has a purpose. They want to find the first multiple of 3 that is greater than 10. That's just starting about quarter of the way down, 328. So this is a useful one, but it's still very similar to the ones we've seen so far. So they start off with a equals 0. With while loops, you usually have to have something defined before a piece of information that you're starting with, because that's the thing that you have to ask. You have to ask about. That's the thing you have to make your condition for. So this is our condition. You can say this is our conditional variable. We're gonna ask MATLAB if this variable fits our condition for our while loop, and then we're gonna say while a is, we want to know a is less than 10. Now, when we do when we did this before with k, they didn't put it in parentheses. I don't necessarily think that you have to put it in parentheses. I'm not sure if it makes a difference. Let's try it both the ways. Let's try a is less than 10 without parentheses. And we'll try it again later with them. And then we're going to go ahead and let the index or the let a be an index variable as well, kind of. We're going to add 1 to it every time we go through the loop. A equals a plus 1. A plus 3, because we want to know multiples of 3. A equals a plus 3. And then what I'm going to do is I'm actually going to suppress that. I'm not going to print that off to the screen every time. I'm going to suppress it. And then I'm going to go and end it. So now it's going to run that program. And then I'm going to go ahead and I'm going to display, or I don't even have to put display. I'm just going to do a minus 3. No, I'm just going to display a, actually. I'm just going to say a, because I want to know the first multiple that's greater than 10. And so that calculated the first multiple greater than 10. And you could do that for the first multiple of 3 greater than 10. You could do this for a much more complex thing. So if you wanted to say that, we'll say that start with a equals 0, and then we'll go to while a is less than 1,467, 104,678, right? And then we could actually say a equals a plus 7. And then we hit return and hit end, right? And then we could display a. Turns out, gotta be kidding me. That's hilarious. 104,678, which is the number I chose, is actually a factor of 7. That's too funny. Oh, that's crazy. Never would have guessed, but apparently it is. Is it? Let's check to see it, unless I did my code wrong. 1,478 divided by 7. Yes. What are the odds that I randomly pick a number that's this huge number that's a factor of 7? That's hilarious. Oh well. Anyway, so that one just turned out weird. That's a 1 in who knows how many chances to get that right. I should go buy a lottery ticket. Okay. Well, anyway. So that's actually a useful use, but a useful way to use the while function, but it's actually not very different than the ones we did up here. We're still using an index every time, but it's just a clever use of the index. We're just adding 7 to it every time, and it did the calculation fairly quickly. So that's also good. Many things that you can do with the while loop. Here's another example. In this one, we're going to I don't know what it's doing here actually. Where does it start talking about it? Oh, here we go. So in this, at the bottom third of page 328, they actually do the problem that we've done before, but they use a while loop instead of a for loop, where they're counting the number of scores greater than 90. And the code is actually very similar, you see, but so this is another example where they're doing something with a for loop that they could have done. They're doing something with a while loop that we already did with the for loop. And again, the code looks very similar, except instead of defining a number, instead of going from 1 to the length of scores, they actually define k equals 0, and they say, well, k is less than the length of scores. You keep doing this loop. So that's just another example of using a while loop to do the job of a for loop. However, in the next one, is the one that I want to look at here. So I'm trying to, okay. In this one, we're actually going to use a while loop to calculate the log of a number. But we're going to use it also to determine whether or not somebody has entered the correct, entered in a number that's allowable to do a logarithm with. So let's take a look at this one. Man, they just don't really do an example that I want to do. I'll have to come up with one myself, I suppose. That's okay. So this one is 329, right in the middle of the page here. We're going to define x to equal an input, a user input. We're going to ask them to enter a positive number or something like that. And so we're going to enter our positive number. Let's say we'll enter 78. And that's fine. That's going to now become x. And then we want to do this while loop. And of course, if you were really going to do this, you'd probably put it into some kind of function or something, or some script file or something. We're going to do while. Now we're going to use our parentheses to see if that changes anything. While x is less than or equal to 0, we're going to do something specific. We're going to display this text. I said positive number. Right? And then after that, we're going to go ahead and do another input. Input enter a positive number right here. And then we'll go ahead and end that. And because I already entered a positive number, what's going to happen to this while loop? Nothing. Because I already entered a positive number. My number was greater than this, and so this statement at the very top became a negative statement, and it skips the loop. Now, if I start off with a negative number, right, and I go ahead and put in negative 89 or something like this, and then I go through this while loop, into the while loop, display, I said positive number, input, enter a positive number, and now it says I said a positive number, enter a positive, it's expecting a positive number. Now, after that, I put in 45 here, and I'm good to go. X is now equal to 45. Then I can execute the command y equals log of x or whatever, and we're good to go. And then they do an fprint after that, where they print off the base. They're using log base 10. I just use log. They're just different functions. But and actually, if I display that, it'll just give me the numbers. Well, where did it go? There we go. If I don't suppress it, it'll give me the answer. But you can use that together with, I mean, because we did this one before with an if else statement, right? We did this with an if statement, if else if statement. But you can also do it with a while statement. So they do the creating factorials, calculating degrees to radians with while loops. They do an alternating harmonic series, if you're even interested in what that is. It's a mathematical thing. I think the most important thing to realize about a while loop is intended to do something until it has satisfied a requirement. And in real life, that is often useful. In mathematics, it can be useful because sometimes you're calculating something over and over and over again, like the harmonic series. If you look on page 333, you can see what the graph of the harmonic series looks like, the graph of the alternating harmonic series. It looks like this thing that goes back and forth, up and down, zigzag, but it gets smaller and smaller and smaller as it goes off towards infinity in its number of terms. So if you try to calculate the harmonic series using a for loop, then you have to choose where to cut it off. You have to, because you can't just keep calculating forever. You can't have a for loop that goes forever, and the harmonic series goes forever. So you have to choose. Oh, I only want to do it for 1,000 terms, or I want to do it for 1,000,000 terms, or something like this. But maybe those last 500,000 terms are so tiny that MATLAB can't even use them to calculate anything. But with the while loop, you can actually put within the while loop, you can say, well, while this certain calculation is greater than this number, then keep doing it. But once it gets smaller than that, cut it off, because those numbers aren't useful to me, right? So that's really what while loops are for. While loops are designed for you to set up a criteria where you want the loop to execute, but there's some criteria that means executing this loop is either not valid, or it's not valuable to you, or useless to you, or something, or maybe it's just something you don't want to happen, and so you cut it off at that, or you do want to happen. It could be the other way around as well, but you cut off the loop when you reach that point. One great thing for this is, let's do an example actually. Let's create an array of numbers. As I was just talking about that, so I could try to think of an example, and now I think I thought of a good example. So I'm going to create an array of numbers called A, and I'm going to put in just a bunch of random numbers. Actually, I'm going to do this differently. I'm going to create the number array that's an empty array like this, so I'll put a 0 in it or something. And then I'll just hit return. And then I'm going to open up that array in my array editor, and I'm just going to put in a bunch of numbers here, really quite randomly. I'm going to just start putting them in all over the place, just clicking, putting numbers in, making this huge array of numbers that are really random and crazy. And I'm going to just do it. I'm going to do all kinds of numbers everywhere. It's like playing Minesweeper. You ever play that game? Putting in all kinds of numbers. All right, that's crazy. It's a 49 by 7 double. Maybe I should give myself some more numbers out here. Just to get it a little more interesting. Never saw an array made like this before, did you? All right, so now it's a 50 by 14 double array. It's got a whole bunch of numbers in it randomly. So what if I wanted to look for a certain number in this array? What if I wanted to find a particular number in this array? MATLAB can actually do that, but you can also do it using a while loop, and you can also do all kinds of other things using a while loop. So let's say that this is an array of temperatures, times of day, and dates, or something like this. And I want to go through, and every day that has a temperature, I mean, these are really big temperatures, some of them, but every day that has a temperature that's greater than 50 or something like that, I want to replace the number in there with some other number, replace it with 100 or whatever, whatever. And I can do that using a while loop, and I can even do it with a for loop. But what if let's see, I'm trying to think of something I can only do with a while loop. Okay, here's something that I can do with a while loop much better than a for loop. I want to go through this array element by element, and I want to find the first day, or the first number that's greater than 50. Okay, so that's going to be a while loop. I'm going to say while A, now let's see if this works. I'm not sure if it's going to work. Let's just say while A is greater than 50. First number that's greater than 50. While A is greater than 50. No, I want to say while A is less than 50. because I want to keep doing it until I reach 50. So while A is less than 50. And let's print A. Let's actually, let's end that really quick. We have to set up ourselves as some kind of index first. So n equals 0, we'll start with, and then we'll do while A greater than 50, I'm going to say n equals n plus 1. And then I'm going to print off A of n. So I'm going to actually display the number that's the first number that's greater than 50 in this array. Now there are ways to do this using MATLAB commands, which are much more, which are probably much faster. But I'm going to go ahead and do this anyway and see if it works. So I'm not sure if it will. Let's end. So while A is less than 50, it didn't like that for some reason. Didn't do anything with me there. I don't know why. So let's say, well, let's do this. If we do it term by term, that's just like using a for loop. I didn't want to do that. Well, let's do it anyway. So while A of n is less than 50, so now I'm actually going to look at each individual one at a time. Now here, so the usefulness of this one is quite good actually. This is something you can't do with a for loop very easily, but you can do with a while loop. In this particular case, what's going to happen is I'm going to look at the first element of A and see if it's less than 50. If it is less than 50, then I'm going to add 1 to n, and I'm going to print it to the screen. And then it's going to go through the loop again, and if n is less than 50, it's going to add 1 to n and print it to the screen, print that next number to the screen. And it's going to do this going one by one through A. It's going to look and see if they're less than 50, and then it's going to print them to the screen. We could also put them in a new array. We could also say that B of n, oops, equals A of n. We could put them in an array like that if we wanted to, or something. And there's a lot of these things, it's 14 times 50, which is 700 of these things, right? So if you're doing this with a for loop and you wanted to find out which ones were less than 50, and you wanted to print them out, you'd have to go through the entire array, even if you only wanted to know which ones were less than 50 and then stop. This one will go for the ones that are less than 50, and as soon as it hits one that's more than 50, it'll stop, and it won't look at the rest of the array, which can be useful in many situations. So then I'm going to press end and see if this works. Array indices must be positive. What happened? Integers are logical values. What is n? N is 0. N equals n plus 1. It didn't increase my index for some reason. I don't know why. Oh, I know why. Because I have to start with n equals 1, not n equals 0. So let's start with n equals 1 instead. So n equals 1, because the first index is not n equals 0. And then we'll do the same thing here. We'll use n equals n plus 1. But we'll do that afterwards, actually. Where's my code? There it is. Put in that next. And then we'll do the n equals n plus 1 here. And then we'll end it. Now we go, what did it do? N equals, n equals a, didn't do it. Why didn't it do it? What did I do wrong? Well, a to the n, a of n less than 50, bn equals an, n equals n plus 1. Is my first number greater than 50? That's probably my problem. My first number is greater than 50. So I did do it. Let's make this first number less than 50 and hit enter, and then try to run this again. Let's run all this again. Copy, paste, run. And now I have a vector v, or b rather, that actually has all the numbers in it that are less than 50 until I get to a number that is greater than 50, apparently somewhere maybe. Yep, because apparently the 52nd element in A is greater than 50. So I printed off all those numbers that were less than 50. Okay. So anyway, lots of different things. I mean, those are just kind of pie in the sky random examples that you can use the while loop for, but there are so many things that you can do it for. So many things you can do with the while loop. We're actually going to see some of these as we get into the break and continue commands here next, which is the last part of the chapter here. So let's take a look at the break command. The break command will stop a loop, will break a loop while or for loop. Anywhere in the loop, it will break it. So if the break command is executed, the loop, it doesn't matter if the loop's in its first iteration or its 500th iteration, it'll break the loop. Usually, the break command is used within an if, else if type of thing, so that you can choose whether or not to break the loop depending on a condition. And so they show some different examples of this. First example on the top of page 336. They start off with, let's clear up here really quick. So they start off with n equals 0 as an index, as a running index, and then they're going to use a while loop. We're going to say while n is less than 10. And then we're going to define a variable a, which is going to be equal to some input that the user is going to input in after they're asked the question. Enter positive number. All right. So that's the input that's going to be put in during the while loop. And so every time it goes through the loop, it's going to ask for a number a, right? And then it's going to take that letter a and put it through this logic statement. Let's say if a is less than or equal to 0, if a is less than, let it go, less than or equal to 0, I want to display positive, please. And then display this program will self-destruct. All right. So then we break. But that's only the first half of things that could happen. If a is less than or equal to 0, that will happen. Then we end that. That ends the if statement. And we go to the end of the program. If a is greater than 0, then we do this. Display the log whatever, and then we display goodness log a. All right, and then we go ahead and put an end to this and we run it. So enter a positive number. I'm going to hit -12, right? And it does that. If I entered a number that was greater than 0, then it would have calculated it. This would have displayed the natural log of the number is and then calculated and displayed that. You could also do what they do just below that, where they say try again. So instead of ending the program with a break, they say if a is less than or equal to 0, display must enter a positive number, and then try again. And then you go ahead and they put in the continue command at that point. The continue command goes back to the beginning of the while function and starts it over. So you have the break, which ends the function, which ends the loop. You have the continue, which restarts the loop, right? And then it asks them again to enter a value. And in this one, we'll just keep repeating until they actually enter in a positive number, right? And there are many ways to do that. The continue function is just one of them. There actually is a different way to use the break function, which they're showing right at about, let's see, where did it go? So it's right about 2/3 way down page 337. In this one, they use an if else function and they put the break inside the else part of the function. So it allows this function to repeat, the while loop will repeat and repeat and repeat as long as the if part is correct. But if ever the else part is correct, if the if part goes wrong, then it breaks only. So in the first one, we did an if statement where the break was there all the time. Didn't matter what happened. In this one, the break only happens if the first part of the if condition is not true. So if candy bars is less than 0, then it displays must be a positive number, and it skips the else part, so it doesn't break the loop, and it allows the loop to reset. So essentially, this one here on page 337 is the same one. It does the same thing as the continue one does halfway down page 336. It just does it a different way. You have to write a few more lines of code instead of just putting in the continue function. So it's just two different ways to do the same thing. You can use the continue function for a very quick fix, or you can actually write it in. The advantage of writing it into an if-else function is you can have multiple else things that can happen, right? So you can have an if-else, you can have an if-else, an if-else, an if-else, and then you can have an else break function. So you can essentially separate a loop to have many different possible outcomes depending on what is put into the loop, right? And that actually goes back to the idea of the flow chart, where you have a flow chart where one thing or maybe multiple things come into a calculation or into a decision or something, and you can have multiple outcomes from that decision. And that's how you do it, is you put inside of a while loop or a for loop, you put if-else statements. And each one of those, or you can put switch case statements as well inside of these loops. But something that gives you multiple outputs for a single input. And in this particular case, there's only two outputs. You have an input that is the number of candy bars, and if that candy bars is less than 0, in other words, a negative number of candy bars, it gives this output of must be a positive number. If it's not less than 0, it's a 0 or greater, then you calculate the cost and output the cost and break the thing. You're done with that function. Right? You could also have one that says if it's 0, then you could say else if equals 0 or else equals 0. else, you would say else if candy bars equals 0. You could say go pick out a candy bar or something. And then that one would not have a break in it. And then the next one would have the calculation. And then you would calculate and break it. So these kinds of programs are everywhere in the world, everywhere. They're in your calculators. They're in computers at the grocery store. They're in your cell phone for doing different things, where it controls what your input can be and controls what the output will be, and prevents what this kind of function does is it prevents the computer from getting stuck doing something that you weren't intending it to do because you made a mistake in your inputs, right? You don't want your computer to get stuck doing something that's impossible because you entered things in incorrectly. Let's imagine that you called the wrong phone number and your phone just dies because you entered the wrong phone number, because it's a phone number that doesn't exist and it doesn't know what to do if you call a number that doesn't exist. But of course, somebody wrote a program for your phone so that your phone knows what to do if you call a phone number that doesn't exist, that doesn't connect anymore, right? In fact, there's all kinds of things. If it doesn't have the right number of digits, if it doesn't start off with the correct 3 digits, if it doesn't have, I mean, there's all kinds of things that if you enter the wrong thing into your phone, there's a program written for, oh, that's the wrong thing. We need to give them some feedback, or we need to start over, or we need to break this loop, or whatever we need to do to make sure that this phone doesn't go off trying to do something that it can't do, or it doesn't know how to do. So those kinds of programs are very common throughout the world. Now you can even put loops within loops within loops. This is very common in programming to have loops within loops. They're called nested loops. The problem with these when it comes to for loops and while loops is all those variables in the loops are now intermixed, interconnected. So you better not use the same variables for index variables. You better not use an I for one loop and an I for another loop unless you're doing it on purpose. So you need to mix up the variables that you use. Use an I, then a K. They do a very simple example of a calculation here at the top of page 341. And these things can get extremely complex. This is why they don't do a whole lot of them. But when you do a loop within a loop, it goes, the program will step into the first loop and do whatever it's told it to do there. But as soon as you step into the next loop, it will stay in that inside loop until that inside loop is done. And then we'll go back out to the outside loop. But when it goes back out to the outside loop, it will eventually go back into the inside loop, and it'll stay in that inside loop until it's done. And then it'll go back into the outside loop, and it'll go around the next time on the outside loop. And then that means it'll go back to the inside loop, and it'll stay inside that inside loop until it's done. So it's kind of like mathematics in that way, where you have parentheses. You do the math in the inside parentheses first, and then the outside parentheses, except in this case, the parentheses repeat themselves, right? They're loops. And so you can do this with while loops, you can do this with for loops. You can do a for loop inside of a while loop. You can use breaks and continues and everything else. But like I said, it can get extremely complex. So let's actually so what we're going to do actually is we're going to return. We're going to actually build a function that does the same thing as the max function. I wasn't reading back from you. So if you have this array, we actually already have. Oh no, we erased our array here. Okay. So we'll use their array. Their array is this one. X equals. I'm going to go just x equals 0 and enter it in here. So their array is 1, 2, 6, 3, 1, 2, oops. 1, 2, 6, 3, and then 4, 8, 2, 1, and 12, 18, 3, 5, 12, 18, 3, 5, and 6, 4, 2, 13, 6, 4, 2, 13. Oops, that 13's in the wrong place. 13. I've got too many things going on here. I don't want to replace with 0. I want to replace with nothing. So we'll just call it that. I think there's a null that I can put in there actually. That doesn't change anything. I want to put in null. Doesn't allow me to do null. Dang it. What did I just do? Delete column. There we go. Delete column. Now it's a 4x5 double, which is what they've got. That's great. We just hit enter, call it good. So normally we can just do the max of X, right? And it will tell us the maximum number in every column. So the first column, the maximum number is 12. Second column, maximum number is 18, so on and so forth. We want to write a program that does this. And we're going to do this using nested loops. Why are we going to do this using nested loops? Because what we're going to do is we're going to go through and we're going to go through row by column. So we start off in the first column, first row, second column, first column, second row, and so on and so forth, right? So we have one index that's going to say which column we're in, one index which says which row we're in, right? And then we're going to go through that. So we're going to have two loops. Two of them they're both for loops. And first of all, we need to know how long we're going to do this. So we're going to set up our index numbers, or the top end of our index numbers is going to be called rows and columns. These two numbers that are the number of rows and the number of columns, right? Rows and cols, like that. And that's going to be equal to the size of X. We could also just say rows equals 4, or rows equals 4 and columns equals 5. But this way we could write a program that would accommodate any matrix that was plugged in. So this tells us rows equals 4 and columns equals 5. And then we're going to go for k equals, so our index variable is k for this one. We're going to go from 1 to columns. So the first time we go through this outer loop, we're going to start in column 1. We're looking at column 1, right? And then we're going to use, we're going to create an array called maximum. We're not going to use max because max is already a command in MATLAB. We're going to create an array called maximum, and we're in the first element, or in the kth element of maximum, which is the first element as we go through the first time. We're going to let that equal the element in the first column, no, the first row in the kth column. So the first time we go through, we're looking at first row, first column element. And we're gonna take that element, we're gonna take the first number right here, and we're gonna put it in the first element of this new array we call maximum. Okay, now we're going to suppress that. We don't want to print that off yet. And then we want to do another loop, another for loop, but this time we're going to go for J, they use J equals, we're going to go J equals 1 to rows rather. So the first time we go through this, we're going to be in the first row. Right? Then we're going to ask a question. If the thing that we just put into X, which was that first element, that first thing, that first number in the array, if X, J, comma, K, the first row, first column, the first time we go through both these rows, in other words, if that is greater than Where's my greater than? If that's greater than the first number we just plugged in, maximum K, then we're going to replace that with the number we just looked at. Maximum K is now going to equal xj. Okay. Now, what does this mean? This seems very enigmatic, I suppose. But what this means is that we've got this box where we're putting all our biggest numbers, right? We're calling this box maximum. And we're looking at the first number in X. We're going to take the first number in X and we're going to put it in this box. Okay. And then we're going to take the next number in the first column of X and we're going to compare it with the number we just put in that box. And we're going to say, is this one bigger than the one that we put in the box? If it's bigger, then I'm going to put it in that box and take out that other one. I'm going to replace the number in the box with the bigger one. And then I'm going to go to the next number in the first column of X, which would be the first column, third row. And I'm going to compare it with the one in the box. And if it's bigger, I'm going to put it in there. If it's not, I'm not going to do anything with it. And I'm going to keep doing that until I get down the first column. And then that number is going to be my first maximum. That's going to be the maximum from the first column. Because I will have looked through all the numbers, compared them all. And if they were bigger, I put them in the box. If they weren't bigger, I didn't do anything with them. I just threw them out. And then I'm going to go back through the loop. And I'm going to do the same thing with the next column. I'm going to put it in the next part of the box because I've already got the maximum from the first column. I'm going to create a new divider in this box for the second column. And I'm going to put the first number in there. And then I'm going to take the second number and I'm going to compare it with the first number that I put in there and see which one is bigger. The bigger number is going to stay in the box. The smaller number I'm going to throw out. Then I'm going to look at the third number and compare them. The bigger number I'm going to leave in the box or put in the box, and the smaller I'm going to throw out. And I keep doing that till the second column is all done. And I found the biggest number in the second column. And I keep doing that until I get all the way through to column 5. And when I'm done. I found all the maximum numbers. And I've got them in a box where the first one number in the box is the maximum from the first, second number in the box is the maximum from the second column, and so on and so forth. So that's what this if is going to do. That's what this if function on the inside is going to do. The other functions, all they do is step us through the rows and columns. They step us through the elements. They go first row, first column, second row, first column, third row, first column, fourth row, first column. Then it goes first row, second column. It just goes down each column. That's all these other loops do. And that's often what nested loops do, is they just step us through a large array of values or numbers or something. So I'm going to end that if function there, and then I have to come in and end my inside for loop here. And this is why we do these indentations, so we can tell which ones have been ended and which ones haven't. And then I'm going to end my last one, which is here. And then I'm going to run that code. And then I'm going to print off X and see if it's, see if it worked. No, sorry, not X maximum. Print off maximum and see if it gives me the maximum numbers. It gives me 12, which is the maximum from this column. It gives me 18, which is the maximum from this. 6, which is the maximum from this. 5, which is the maximum from this, and 13, which is the maximum from that. And go figure, MATLAB already has a function for that. We just used it. And it actually does it all at once instead of going through nested for loops. Because nested for loops can be very time consuming and computing consuming. But if you don't have MATLAB, or if you're not doing something exactly like that, you can use for loops. You can use nested loops to do that. Sometimes we use unnecessary nested loops because we think we need them, but we don't actually need them. And that actually can create a lot of hang time in your program, a lot of computing time and a lot of work in your program. Usually the reason for that, usually the reason that happens is because the programmer does not realize that they can use two numbers, they can use one of the index numbers from one of the loops for two different calculations or for two different things inside the loop. So sometimes it's much to our advantage to think it through and say, do I need this nested loop for real, or can I use something that's already going on in this loop to make this happen? In general, loops are not very efficient, and they can actually be quite dangerous. It's really easy to create a loop that goes forever. Really easy. And when that happens, your computer just locks up. It doesn't know what to do. It just keeps computing forever and ever and ever and ever and ever and ever. And MATLAB will just essentially sit there and blank, and you won't be able to do anything with it. MATLAB now, I believe, has built-in checks to check for things like that, to check for what we call infinite loops. And so it may bring up some kind of an error for you or something. But if it does get into that state, I think that trying to remember, I think it's Control C or something like that. Control C, Command C or something like that, that will break the loop. And it'll essentially stop whatever MATLAB's doing and return you back to your command window. And it may not be that anymore. I'm pretty sure that it was Control C at one point, but I'm not sure if it still is. It's been a while since I've been stuck in an infinite loop in MATLAB anyway. I got stuck in an infinite loop in Python a couple times recently. But that is the idea behind these repetition structures, or as most people call them, loops. There are many, many things you can do with them, but many of those things you can do much quicker using built-in code in MATLAB, which is useful. So you still will see for loops in MATLAB. There's no question about that, but not as often as you'll see them in other code languages. In other languages, you see loops just so many times that there are entire libraries of functions that people write that you can download so that you don't have to write the loop. The loop is built into the function and you can just plug in the numbers. MATLAB, of course, has those things built in and doesn't have to worry about them, which is great. Love it. They also talk about timing your loops here. Remember the tick-tock function that we used before, and we also used the clock function before. There's also an elapsed time function, e-time. They introduced it on page 341, where it actually tells you how much time has elapsed if you set t0 equal to clock and then use e-time later. It'll actually, and then you use the numbers that you've used or the variables you use. It'll actually tell you the elapsed time, or you can use the tick-tock function, or you can use. There's many ways to time your programs to see if your program is efficient as it can be. For most of the programs that you write in this class, that will mean nothing. If you get into programming in a big way, it will mean everything, because time is money when it comes to computing, no doubt about it. All right, that essentially takes us to the end of chapter 9. And if anybody has any questions about homework chapter 8 or loops in chapter 9 or anything, we can answer them now. What time is it? We've got some time left. Got about 30 minutes left. Does anybody have any questions or concerns or homework problems or anything like that? None, no? Logan, you got anything for us?
No.
No. Well, if that's the case, then we'll let you go. Have a great day. Enjoy spring break next week. You have lots of time to work on this chapter 9 stuff. And you have till Saturday to turn in chapter 8, apparently. You also might be thinking about ideas for a final project. I still haven't come up with one that I really am married to. So if you have an idea, if you want to propose a possible programming final project, you're welcome to. I can consider them. Like I mentioned in the past, I've done lots of games like card games and dice games, but we've done some other things as well. So if you have an idea, I'm open to hearing it. Enjoy your week off. See you later. We're all done here.